Welcome to the podcast. This is Mr. Sadler,
Mr. Johnson.
and we're going to talk about Newton's first law. So, Mr. Johnson, what is Newton's first law?
It's his first of three laws, the one where it says when something at rest stays at rest, and
When something's in motion, it stays at motion. So, so I'd like to talk about that a little bit because a lot of times students think that the natural state is for things to come to rest. Like if I'm playing pool and I hit the pool ball, it eventually stops. So how can Newton's first law be correct if the pool ball is coming to rest?
well, there's a lot of other things that go into the pool ball coming at rest. I mean there's the table. There's the felt.
So what force is on the table that is making it slow down and stop?
Oh, well, one is friction.
Friction. So a lot of times if we think about something in outer space where there is no friction or very little friction, you'll see that a body in motion tends to remain in motion, and a body at rest tends to remain at rest. Another nice example is I'm driving in a car and I turn quickly to the left or have a turn to the left, and if I turn to the left, then I'm thrown to the right because the car is moving to the left, but my body tends to continue on in a straight path. It wants to continue on.
See, I always thought that was the car actually was making me do that, whereas I'm just staying at rest.
Right.
That's
like
interesting.
The car, if you didn't have a seatbelt on, or even worse, if you were in a Jeep with no seatbelt, pretty soon you're out on the road. So.
And as a safety disclaimer, please do not try this at home.
So I think that's part of the reason that four-wheelers are so dangerous sometimes is because, they don't have a seatbelt, and it's easy to be thrown from those. On a motorcycle, how do you defeat that on a motorcycle? So when you're going around the turn on a motorcycle, what do you do?
Well, I don't know how to drive them, but I do see motorcycle people lean into the turn.
Yeah, absolutely, leaning into the turn, right. So the other concept that we want to talk about is inertia.
So law of inertia.
So Newton's first law, the law that we just talked about, was really it's Galileo that came up with the law of inertia. Mm-hmm. And so what is inertia?
Well, inertia is the natural tendency of an object to remain at rest or to remain moving with constant speed in a straight line.
So can you think of an object like a bowling ball?
Bowling. I like bowling.
So a bowling ball, it's a lot harder to push a bowling ball and get it rolling than it is, for example, a golf club. So why would that be in regards to inertia? Why is it harder to get that bowling ball moving?
Well, if you just look at it right away, a bowling ball is obviously really, really bigger than a golf ball.
Right.
So if it's that much more bigger, I would think something that's more massive.
Right. It's because of the more mass. Absolutely. It's more mass, so it requires more force to get it moving. So therefore, if it requires more force to get it moving, it also requires more force to do what?
To stop it.
It's to stop it, correct.
More mass. So once that bowling ball gets moving, which one does it slow down faster, the golf ball or the bowling ball?
So the bowling ball would take more inertia to stop, okay, if they're both going at the same speed. So let's actually compare that to like a school bus compared to a Mini Cooper.
Okay.
Okay. So the comparison would be something like that. Get back into a car situation. So the school bus would have more inertia. You can see videos like this online where large vehicles hit small vehicles, and what happens is the small vehicle takes the brunt of the hit, so because of more inertia. So we did the investigate today. I would like to talk a little bit about release height of the ball in regards to a roller coaster or something like that. If I release it from why. We get on a roller coaster and the lift takes us to the top of the roller coaster. Will the roller coaster ever make it that high again? The answer is no, because of the friction again. Okay, but if there was no friction, then the release height would be the recovered height. Okay, it would make it back to where it started. Okay, so that's Newton's first law again, and we've discussed a little bit about inertia. Signing off, this is Mr. Sadler.
Mr. Johnson.